So we're continuing to look at independent demand when it comes to inventory management. So fixed order quantity was where we order the same quantity every time. So we looked at when do we need to place the order and how much do we order? What is that quantity that minimizes our inventory costs? Well, now let's look at fixed order interval. Fixed order interval is when orders are placed at a fixed time. So we could set that we're going to place our orders every Monday, or it could be the third Wednesday of each month. So we have a fixed time interval between orders. Well, we need to first figure out what that interval is, and then we need to figure out how much we're going to order each time. So what's the order interval and what's the order up to level? The order up to level is how much inventory we need to have once you take into consideration how much inventory we already have on hand plus the order that will arrive. And so with fixed order interval, we're going to order a different amount every time we place an order because we're going to order up to a certain level. And if we have lots still on hand, we won't have to order as much. But in this case, with a fixed order interval, we're going to place our orders at the same time every time. So we have a fixed time we place the order. Fixed order interval is used by wholesalers and retailers, especially when you're ordering multiple items from the same supplier. Benefit of this is it requires only periodic checks of your inventory level, so you know that you're placing your orders on Tuesday. So Monday you can check the inventory levels and that'll help you figure out how much to order. So let's look at how we would calculate order interval and order up to level. All right, so the formula to find the order interval looks a little intimidating. So that's the formula you see here on the left. What it does is it takes into consideration the ordering costs. And because fixed order interval is often used when you're ordering multiple items from the same supplier, we typically have a cost to place the order, and then we have an ordering cost that's dependent on the number of different types of products you're ordering. So what you see here, this N times S, is the number of different SKUs or different types of product you're ordering times the ordering cost per product. So think about, okay, well, I'm Home Depot, and from my supplier, I need doorknobs, and I need screws, and I need nails. Okay, so 3 different types of product, 3 different SKUs. There's going to be a cost to place the initial order to the supplier, and then a cost related to the number of different types of product I order. Then we have to consider the cost to hold the inventory. Okay, so your order interval is basically looking at the trade-off between ordering costs and holding costs. One's on the top of the formula, one's on the bottom. So when we look at the holding cost, here, holding cost is listed as a percentage of the value of the product. So the sum D times R says, okay, how many doorknobs do I need? So that's my demand for my SKU, for my item. And what is the value of that item? How much does a doorknob cost? Well, if we take the value of all the doorknobs we need to order, a percentage of that value is the holding cost. So let's work through a problem. So 3 parts are purchased from a supplier. The cost of placing an order for 1 SKU is $1.50. Each additional SKU is 50 cents. The annual carrying cost is 24% of the unit cost, and the company works 250 days a year. We have 3 different items that we are getting from the supplier, SKU 1, 2, and 3, and we're going to need different amounts based on our forecasted demand. So demand per year for item 1 is 12,000, For 2, 8,000. For 3, 700. And the price per unit is 50 cents, 30 cents, and 10 cents, respectively. So then how do we figure out the order interval? So in our formula, our order interval, let's start with the top. So square root of 2 times, and this is where our ordering costs are. So in this case, it costs us $1.50 to place the first order, and then any additional items we order within that same order, then that's going to cost an additional 50 cents. So in this case, the S plus NS is the $1.50 plus 50 cents for the second SKU plus 50 cents for the third SKU. So $1.50 plus 50 cents plus 50 cents. If you want to break this down to match the formula of S plus NS, then what you're saying is it's $1 to place the order plus 3 SKUs at 50 cents a piece, right? So the total ordering cost, well, that's $1 plus $1.50, $2.50. Okay, you get the same thing here with the $1.50 plus 50 cents plus 50 cents. The ordering cost is $2.50. Now, on the bottom of our formula, we have our annual carrying cost. That is 24% of the value of what we're ordering. So the sum of D times R, we need to figure out what that is. Well, if the demand for SKU 1 is $12,000 and the value of SKU 1 is 50 cents a piece, then D, that's this, times R, is going to be, well, 12,000 times 0.5, right? 6,000. And for SKU 2, our forecasted demand is 8,000. The value of that product is 30 cents a piece, so that's worth 2,400. And then the third item, we need just 700 of them, and they're worth 10 cents each. So this part of the formula here, where it says the sum of D times R, that's where we're going to take the value of everything we're ordering. So 12,000 units at 50 cents a piece, 8,000 units at 30 cents a piece, and 700 units at 10 cents a piece, which in total, 6,000 plus 2,400 plus 70 is 8,470. Okay. So on the bottom of our order interval formula, it's 0.24 times 8,470. So if we simplify this here, the square root of 2 times 250, that was our ordering cost, divided by our holding cost, which is 24% of the value of our product. Okay, so let's do that calculation. So 2 times 250, right, gives us 5. So we're going to have the square root of 5 divided by, and then 24% of 8,470 is what? 2,032.8. Okay. And we can take the square root of that. All right, so 5 divided by 2032.8 and square root of that. Oh, and when you do that, you get what? 0.0496. All right, so the order interval, that 0.0496, is a fraction of a year. Now, this particular company works 250 days a year. So if we need to order every 4.96% of the year, then our order interval is 0.0496 times the 250 days that we work in the year. 0.0496 times 250, and we get 12.4. So this is 12.4 days. So in this case, our order interval, the amount that we're going to place our order every 12.4 days. So fixed order interval, every 12.4 days, we're going to place our order. So the next thing we'd have to figure out is how much do we order? And to figure out how much we order, we have a different formula for that. So this formula is called the order up to level. Okay. And for simplification's sake, let's just use a different example instead of carrying on from the one before. But let's look at how much we need to order up to. So let's look at this formula. This formula includes the order interval, which you could find with the previous formula we just did. And it recognizes that we have a period of time between when we place our orders, and we have lead time, right? Once you place your order, it takes a while before the order comes in. So we need to make sure that whenever we place the order, we have enough for the period of time after we receive our order until our next order, and that period of time between when we place the order and when we receive it. So order interval plus lead time. So we're going to make sure that we have enough, which means we have to look at our average demand and figure out how much we're going to need for that period of time. Then we also consider the fact that sometimes we might use up the inventory quicker than we planned. So we're going to add a little extra based on the standard deviation of our demand, and it's going to take into consideration that variability across the order interval and lead time. So we need to have enough still across the same amount of time, but we want to have a little extra just to be safe. So in the formula, you see a Z here, and the Z is our safety factor. Okay, so when we talk about safety factors, we need to figure out what that Z score is based on service level. So when we talk about service level, we're talking about the percentage of time you want to have enough. Well, why don't we want enough 100% of the time? Well, if we have enough 100% of the time, we're going to need a lot of extra inventory just in case. And that causes cost, right? We have to store it. Maybe it goes bad, loses value. So we recognize that it's very expensive to have 100% service level. So we're willing to not have enough 100% of the time. But how much are you willing to give up? Well, when it comes to service levels, there are kind of three most popular ones, and that is to have enough 99% of the time, 95% of the time, or 90% of the time. And these service levels are tied to Z scores, right? The standard normal distribution table. So let's figure out what the safety factor would be based on these service levels. So you want to have enough 99% of the time, 95% of the time, 90% of the time. So to do this, we need to look at a standard normal table. Okay. And in our standard normal table, well, apparently I've written on this one already, we want to find where we have a Z score of 99%. So we look inside the table, because when you look at a standard normal table, the area inside the table is showing you inside the graph. So a standard normal table has z equals 0 in the center, and then it goes out negative one direction and positive the other. Okay, so negative one, positive one as we go out. So what we want to know is we want to know what is the z-score when we have 99% of our data to the left of that z-score. So we go into the middle of the table and we're looking for the closest number to 0.99. All right, so here we have at 2.31 a 0.98928, at 2.32 a point, at 2.30 is 0.989, at 2.31 it's 0.98956, at 2.32 it's 0.9893. So really, when it comes to 99%, it's really somewhere in between 2.32 and 2.33. Okay, so we'll use a z-score of 2.33. Okay, so if we go back to our level here, if the service level is 99%, then we're going to use a z-score of 2.32 or 2.33. So really it's right there in between. Okay, now what about a 95% service level? Okay, for a 95% service level, we want to know the z-score where 95% of our data is to the left. So what we're looking for is we're looking for the number that gets us closest to 0.95. So notice 1.60, 1.61, 1.62, 1.63, 1.64 puts us at 0.9495. Okay, so here at 0.9495, 1.64, that's really the closest we get to 0.95. Okay, so let's go back. And our z-score, oops. Would be about 1.64. Okay, 90% service level, we go to the standard normal table. We're looking for 90%. So notice at 1.29, that's 0.90. At 1.28, it's 0.89973. So at about 1.28, that's the closest we get to our 90%. So if we want a 90% service level, we're going to use a z-score about 1.28. Okay. All right, so go back to our order up to level. We recognize that we need to make sure we order enough so that we cover the amount we're using over time between when we place orders and the lead time between when we place the order and it arrives, plus a safety factor that allows a little bit extra just in case, because we don't always use up the same amount of inventory every day. So we identify a service level. How much do we want to make sure that we have just in case? So the service level is the percent of time that you have enough on hand. Why don't we go even lower and have a service level, let's say 50%? Well, if your service level is really low, then you're constantly running out, which means you have to pay for expedited delivery, and it can be costly when there's back orders. So we want to have enough on hand, but not too much. All right, so let's calculate our order up to level in this scenario. So let's assume that the demand is 30 units per day, and we have a standard deviation of 3 units per day. So we don't always use up the same amount of inventory. Our desired service level is 99%, and we have 71 units on hand when we place our order. The The lead time is 2 days. The order interval is 7. What is our order up to level? So we need to then use this formula here to do our calculation. Okay, so average demand is 30 units per day. Our order interval is 7 days, plus our lead time is 2 days. Notice how the demand and the order interval and the lead time are all in the same units. They're all in days. You got to make sure they match. All right, then we need to add our safety factor. If we want to have enough, okay, 99% of the time, then we're going to need a Z-score of 2.32. Okay, and we're going to multiply that times our standard deviation of 3 units per day, again in days, and then take the square root of our order interval, which is 7 days, plus our lead time of 2. So then we just need to crunch the numbers. So 30 times 9 plus 2.32 times 3 times the square root of 9, which is 3. Okay, so let's see what we get here. We get 2.32 times 3 times 3. So we have 20.88. And then we have 30 times our 7 plus 2, which is 9, so 270. So 270 plus our 20.88. And we get 290.88. Now, whenever you're dealing with inventory, you need to ask yourself, can I order partial units? And if you cannot order partial units, then you always must round up. So in this case, our order up to level is 290.88, but we can't order 0.88 of a unit. So in that case, the order up to level is 291. We always round up. Even if it was 290.001, we would still round up to 291. So then our question is, what is our order quantity? When we place the order, we need to make sure that however much we have on hand plus the amount we order gets us up to that 291. Well, if when we go to place the order, we have 71 units on hand, then the order quantity is going to be the 291 minus the 71 units on hand. And so then our order is going to be 220 units. So order up to level is how much we need to make sure we have up to, given the amount on hand and the amount we order. So then the order quantity takes the order up to level and subtracts the amount we already have on hand.